still factoring quadratic equations. We are building our repertoire one step at a time. Today we're going to talk about the difference of squares. If you remember when we had, I gave you the name, but you probably don't remember it, conjugates. So if I had something like 2a plus 5 and 2a minus 5, where it was the exact same thing with the exception of the sign, when we multiplied it out, we would get the exact same number on the inside with opposite signs, so they would cancel, and we'd be left with 4a squared minus 25, because 5 times 5 is 25. Okay, so we got to think about that when we come across polynomials, specifically binomials, that are a difference subtraction of perfect squares. We can factor them using this process, just going backwards. Okay, so take a look at these two examples. We have 64m squared minus n squared. Those are both perfect squares because 64 is a perfect square, m squared obviously perfect square, and n squared. So we can automatically factor that to 8m plus n and 8n minus n. It's that simple. Okay, so take a look at the second example, because we keep adding all these skills and all these steps together. So in this first one, while I see as x squared, I don't see a number that's a perfect square, but I do see a common factor that I can divide both of them or factor out. I'm going to factor out a 5y. When I do that, I just have x squared minus 100. Now I have a difference subtraction of two perfect squares, so I can go one step farther. X plus 10, x minus 10. So we're going to keep going. All right, everybody see that? The same thing is true. I'll give you a different look at the example in the box. Usually we have variables in the first term and not in the second term, but this one works the same way. It is going to be 9 plus c and 9 minus c. All right? And you can always double check that by multiplying it out. So 81 minus 9c plus 9c minus c squared, and that's what we get. So there's our answer. All right, now what happens if we get more complicated? If we look down here on the bottom, we have not only perfect squares, but check this out. M to the fourth is a perfect square of m squared. So I can take this one, and 16 is 4, so we got 4 plus m squared and 4 minus m squared. Now, when you have a sum of squares, that's prime. I cannot take this one down any farther. But if you'll notice, 4 and m squared are still perfect squares, and it's a difference. So I've got 2 plus m and 2 minus m. And over here, I still keep the 4 plus m squared. And now it's factored all the way down. All right, the same thing is true on this one. Check this one out. 256 is 16. And x to the fourth makes that x squared. And 1 is always a perfect square. Plus 1, minus 1. Now this one's done because it's a sum. I can't do anything with that one. But over here, they are still both perfect squares. So I've got 4x plus 1 and 4x minus 1. And now I'm done. See, so I am applying that difference of squares twice. One to the first and then one to the second, but only the one that is a difference, not that is a sum. Okay, let's try this one in the box. Again, perfect squares gives me y squared plus 1, y squared minus 1. This one's done. I cannot do it, even though they are both perfect squares, but it is a sum, not a difference. But this one is a difference, so I can go y plus 1, y minus 1. And now I'm finished. So we're just applying that step twice. Now, we can also apply the previous steps that we've learned. So take a look at this first one right here. W to the fourth is a perfect square, and actually 144 is a perfect square, and so is 4. So I lied. We can actually do this. So I've got 2w squared. But you know what? I apologize. Because what's always our first step? Our first step is always, can we take out a factor? And the answer to that question is yes, we can factor out a 4. So 4 cubed minus 36, because 36 times 4 is 144. I'm pretty sure. I better double check my math now. Now I'm having reservations. 36 times 4? Yes. All right, good. So now in here, this is a difference of perfect squares. So I've got w squared plus 6 and w squared minus 6. And while I know some of you are maybe looking at this one and thinking, oh, we can go again, the difference is that 6 is not a perfect square. So while it's w squared is, and we got a minus, 6 is not, and we are done. Now what happens if you wouldn't have seen that 4 the first time around? Well, it would have given me, it just would have given me a 2 in each one that you could have factored out. I'm not going to show you. I think you got it. All right. How about this one? Look at this one. Let's think back to all of our factoring tricks and trades and steps that we do. First step, can I factor something out? Now, I can't factor out any a's, but I'm pretty sure I can take a 2 out of all of those terms. So if I do that, I get a to the third minus 5a squared minus 4a plus 20. And now I have a 4-term polynomial in there, and really the only option there is, can I group? The answer to that question is yes, you can. So in the first two, I'm going to take out an a, and I get, actually a squared, sorry, and I get a squared times a minus 5. Over here, I can take out a negative 4 because I want a minus 5 in there. So now inside of my second set of parentheses, I can group a squared minus 4 and a minus 5. And I still have that 2 out front. But are we done? Check this out. A difference of perfect squares. So a plus 2, a minus 2, and then a minus 5. Wow. So many things to remember. So many things. But that's why we take our time. That's why we build one at a time. All right? Take a look at this next one. It's a multiple choice problem, and it gives you an expression or an equation, which is, it says, which is a value of x when y equals 0. So guys, we just set it equal to 0, x to the third plus 2x squared, minus x minus 2 equals 0, and we solve it. Okay, well, there's 4 terms. Can I take anything out of all 4? No. Can we group? Yes. So take out an x squared, I get x plus 2. Take out a negative 1, I get x plus 2. So I can group x squared minus 1 times x plus 2. Wait a minute. X plus 1, x minus 1. I know when I was first learning to do the difference of squares, I would always forget that 1 is a perfect square. But after a while, you'll go 1. Ooh, I can do that again, and you'll figure that out. So then my answers, remember, if we're solving, you set every factor equal to 0. So x plus 1 equals 0, x minus 1 equals 0, and x plus 2 equals 0. So we get x equals negative 1, x equals positive 1, and x equals negative 2. So which one is a possible answer? Negative 1, 0, positive 2, or 1/3. The only option, the only one that's up there is the negative 1. So it is A. Your assignment is going to be, it's going to seem like a lot, but remember it's only evens. Now, if you get going on this assignment and you would like more practice, go ahead and do the odds, guys. I'm not going to stop you. It's great practice, all right? The more you practice, the better you're going to get at it, all right? But it is right there on this page, 16 through 46 even. There's only 16 questions. Remember, we want it factored down. First step, always look for something that you can take out of every term. Then we're going to look for trinomials. You're going to try and factor it into 2 binomials. If it's a difference of perfect squares, there's 2 binomials. If it's 4 terms, you're probably going to have to use grouping. All right, tying everything all together. If you have any questions, as always, please come and see me. All right, good luck.